Have you ever wondered what the most powerful event in the universe could be? Well, let's take a moment to ponder. You might think of supernovas, the explosive death of a star, radiating as much energy as the sun is expected to emit over its entire lifespan. Or perhaps you think of black holes, those enigmatic regions of space-time exhibiting gravitational acceleration so strong that nothing, no particles or even electromagnetic radiation such as light, can escape from it. But what if I told you there's something far more powerful? Something so energetic and enigmatic that it outshines the entire galaxy it originates from, even if only for a brief moment. This phenomenon, my friends, is known as a gamma-ray burst, or GRB for short. Gamma-ray bursts were first discovered back in the late 60s by military satellites designed to monitor potential nuclear tests. But instead of picking up signs of terrestrial squabbles, these satellites picked up something far more intriguing. They detected unexpected, yet unmistakably powerful bursts of gamma rays, the highest energy form of light, coming not from the Earth, but from deep, deep space. These bursts were brief, lasting from a few milliseconds to several minutes, but in that short span of time, they released more energy than the Sun will in its entire 10 billion-year lifetime. Let that sink in. More energy than our Sun, the heart of our solar system, will ever produce, all released in a cosmic blink of an eye. For decades, these gamma-ray bursts remained a mystery to scientists. They were like cosmic fireworks, lighting up the universe in a brilliant display of energy and then disappearing just as quickly as they had appeared. But where were they coming from? What was causing these incredible bursts of energy? And so, the hunt began. Astronomers and scientists around the world dedicated their lives to unraveling the mystery of these cosmic fireworks, and what they found was nothing short of astounding. So, what exactly are these gamma-ray bursts? Hold on to your seats because we're about to dive into the universe's most powerful phenomenon. Gamma-ray bursts, or GRBs, are blindingly bright and incredibly energetic explosions that occur in distant galaxies. They are the supernovas of the cosmic world, a spectacle that outshines everything else in the universe. Imagine, if you will, a celestial firework that is so powerful, it puts our humble sun to shame. Now, these aren't your typical explosions. GRBs are the brightest and most energetic events known in the cosmos. To put this into perspective, a single burst can release more energy in a matter of seconds than our sun will in its entire 10 billion-year lifespan. It's as if all the energy the sun has been conserving for billions of years is spent in one grand cosmic spectacle. But not all GRBs are created equal. There are two types, each with its own unique characteristics. First, we have short-duration GRBs. These are the sprinters of the cosmic race, lasting less than 2 seconds but packing a punch with their high-energy gamma rays. On the other hand, we have long-duration GRBs, the marathon runners. These can last anywhere from 2 seconds to several minutes, making them the longest-lasting gamma-ray events known to us. They are typically accompanied by a supernova or a hypernova, which are amongst the most powerful explosions in the universe. But what makes GRBs truly fascinating is not just their power, but their mystery. Despite being the brightest events in the universe, we still don't fully understand them. They are cosmic enigmas, their secrets hidden deep within their brilliant light. So, you might be wondering, how do these extraordinary cosmic explosions occur? What triggers this release of gamma rays, and why are some bursts short while others are long? The answer to these questions takes us into the heart of one of the most fascinating topics in astrophysics, a journey that will take us billions of light years away from our own galaxy. But what causes these extraordinary cosmic explosions? That, dear listeners, is a question that we'll explore in the next scene. The origins of gamma-ray bursts are linked to the most catastrophic events in the universe. They are the labor pains of cosmic giants, screaming out into the void as they undergo dramatic transformations. Let's take a journey into the heart of these phenomena. The long gamma-ray bursts, those that last for more than 2 seconds, are the offspring of massive stars. These stars, much larger than our own sun, live fast and die hard. When such a star has exhausted its nuclear fuel, it can no longer sustain itself against its own gravity. The core collapses, creating a black hole, and the outer layers of the star are blasted off in a supernova explosion. This process releases a tremendous amount of energy, some of which is in the form of gamma rays. These rays are shot out into space in two opposite directions, forming a gamma ray burst. Then we have the short gamma ray bursts, lasting less than 2 seconds. These are believed to be the result of the collision of two extremely dense objects, neutron stars or a neutron star and a black hole. Imagine two cities each the size of Manhattan, but with a mass greater than the Sun, spiraling towards each other at a significant fraction of the speed of light. When they collide, the energy released is so immense that it outshines the combined light of all the stars in the observable universe, if only for a fraction of a second. These births, though violent, are not in vain. The elements produced in these cataclysmic events are scattered into space, enriching the universe with the building blocks for new stars, planets, and possibly life. Despite their violent birth, gamma-ray bursts have a significant impact on the universe. They are the heralds of change, the harbingers of transformation, the cosmic fireworks that mark the end of one stellar life and the beginning of another. The impact of gamma-ray bursts extends far beyond their place of origin. Like cosmic cannonballs, these bursts charge through space, their energy radiating across galaxies. But what happens if one of these energy bullets were to strike our home, planet Earth? Let's imagine a scenario. A gamma-ray burst, born from a collapsing star, hurtles through space. It's thousands of light years away, but in the grand scale of the universe, that's practically next door. This burst, carrying more energy than our sun will produce in its entire lifetime, strikes Earth. Our atmosphere, a mere veil against this onslaught, absorbs the high-energy photons, causing a chain reaction that depletes the ozone layer. With our protective shield diminished, harmful solar radiation reaches the surface, potentially leading to a mass extinction event. Sounds terrifying, doesn't it? But before you start building your underground bunker, let's bring in a bit of perspective. Gamma-ray bursts, although incredibly powerful, are also incredibly rare. The universe, vast and infinite, has seen only a handful of these events in its multi-billion-year history. The chances of a gamma-ray burst affecting Earth are astronomically small. To give you an idea, imagine winning the lottery, not just once but twice, back-to-back on consecutive days. The odds of that happening are still far greater than the Earth being hit by a gamma-ray burst. So while the potential impacts are catastrophic, the likelihood is minuscule. Moreover, scientists believe that a gamma-ray burst has to occur within a few thousand light-years of Earth to cause significant damage. Given the scale of the universe, this is a relatively small radius. In the grand cosmic lottery, we are not likely to draw the short straw. So, should we be afraid of gamma-ray bursts? Well, they are a fascinating and formidable display of nature's power, but statistically they're not something that should keep you up at night. Gamma-ray bursts may be frightening in their power, but they also hold significant scientific value. Indeed, the study of gamma-ray bursts opens up new frontiers in our understanding of the universe. These cosmic phenomena are like windows into the past, allowing us to peer into the early universe. Because these bursts are so powerful, they can be detected from extremely distant galaxies that formed billions of years ago. By observing gamma-ray bursts, we can thus gather valuable information about the conditions of the universe in its infancy. In addition, gamma-ray bursts are closely linked to the formation of black holes. This connection offers us a unique opportunity to study these enigmatic objects. When a massive star collapses to form a black hole, it can trigger a gamma-ray burst. Observing this process gives us insights into the life cycles of stars and the mysteries of black hole creation. Moreover, gamma-ray bursts are laboratories of extreme physics. They involve conditions of immense gravity, density, and temperature, conditions that we simply can't replicate on Earth. By studying these bursts, we can test our theories of physics under the most extreme circumstances and refine our understanding of the fundamental laws of the universe. Interestingly, gamma-ray bursts could also serve as cosmic measuring sticks or standard candles. Because we understand the processes that create these bursts, we can estimate their intrinsic brightness. By comparing this to their apparent brightness as seen from Earth, we can deduce their distance from us. This could provide a new method for mapping the cosmic landscape and measuring the scale of the universe. In essence, while gamma-ray bursts are among the most violent events in the cosmos, they are also among the most informative. They provide us with a wealth of knowledge about our universe and its workings. From destruction comes knowledge, such as the paradox of gamma-ray bursts.